Hey everyone, welcome to a new video. I recently gave a talk at Microsoft's Build AI Day on the 1st of March 2024, and that talk was about the Azure OpenAI Assistant API from a developer's perspective. So I thought I would redo that talk here on the channel for all of you. Now, what we're going to look at, we're going to look at a couple of things. First of all, an introduction to the OpenAI APIs in general. Then we'll take a look at the chat completions API that, well, if you're building LLM applications today, that should be a very well understood API. And then we'll talk about the main part of this presentation, the Assistants API, which is in preview today in Microsoft Azure OpenAI, and it's still actually in beta also at OpenAI. Now, of course, when we are building things like an assistant, we typically wrap it up in some kind of user interface and have a chat experience for the user. That's basically exactly the same thing that ChatGPT is doing. In this case, this is ChatGPT with the model GPT-4 answering the questions. And a couple of key points here is, of course, that you can tell the model how it should interact with you and how it should respond with you. So when I ask to explain the chat completions API briefly, it'll do so in a bullet style because I've asked it to do so. In a follow-up question, when I'm asking, give an example in Python, it knows or thinks it knows that it has to answer me with a Python example of the chat completions API. One of the key things here that are used to build this kind of interactive experience is, of course, the fact that you keep chat history. You have to maintain the state of the previous conversation in some shape or form, or otherwise this will not work. And you'll see that the Assistants API is working very differently at that level as the chat completions API. Now, sadly, ChatGPT did not give me a good answer here. It basically was using the completions API instead of the chat completions API. It was using an older model like TextDaVinci 003. And if you were to use the most recent OpenAI library for Python, well, then you would have to instantiate that library and you would have to create a client in your code. And that's not something that was done here. Okay, let me try to do a little bit of a better job than ChatGPT to explain what the OpenAI APIs are, and with the focus on Azure, but in essence, it's the same in OpenAI. Although there are some minor differences, if you really start implementing them at a low level, you'll see that there are minor differences between the APIs. Now, the first API is the completions API. That completions API is a much older API, and it's not meant to work with chat models. So there you work with models like now, for example, GPT-3.5 Instruct. You give it a prompt and you get an answer to the prompt, and that's basically it. We don't see that in use as much today as, of course, in the past. Most people will use the chat completions API. And of course, the chat completions API is optimized to use with chat models like GPT-3.5 Turbo or GPT-4. And of course, the chat completions API, because it's built to maintain chats with end users, it has this concept or an ability to work with chat history, plus some other features that it has. Now, there's a new API called the Assistants API. Now, it's not that new if you're working with OpenAI directly. They launched it somewhere last year, I think October, November 2023. But this is quite a recent addition to the Azure OpenAI APIs. And in Azure, it is in a preview state. Some pieces that are available in the OpenAI Assistants API are not available yet in the Azure OpenAI APIs, but that will come soon. It's important to note here that this Assistants API is not a replacement right now for the Chat Completions API. So don't worry too much about that. When you're building production level applications, you'll use this Chat Completions API still. And to put this API a little bit in perspective, you see some example code here. I won't go into too much detail, but the most important thing here is, after I have instantiated a client that in my case connects to an OpenAI instance in Sweden, I'm calling the chat completions create method here. And the things I need, the basic things I need is first of all the model that's going to do the completion for me. In this case, that's a deployed model. I gave the name GPT-4 Turbo to that model deployment in my Azure OpenAI instance. And then the thing it has to complete is the messages parameter. It's what's inside that parameter. And we're using there a variable message text, which is holding a content that you see here. Message text is basically an array of Python dictionaries, and you can immediately see that there are different kinds of interactions with the system. You have role system and then user assistant pairs that are in that list. The system role is, of course, the system prompt. The system prompt, you are telling the assistant what it should and should not do. You might give it a name and other kinds of information. And then you have users asking questions with the assistant responding. Now what you can see here is actually that we are now at a second iteration here in a conversation. The user is asking a second question because the first question was, what's the world's tallest building? That's probably the Burj Khalifa as of the knowledge cutoff of 2023. And the assistant has responded. So in a previous chat completions call, you as a developer are responsible for capturing, of course, the assistant's response. And then later for follow-up questions or to provide chat history, you must make sure that the assistant response is also within this message text here. Now, there are many ways that you can optimize this array, so I won't go too deep into that. But the reason that the question end in 1920 works is, of course, because you have provided the chat history. Now, the fact that you have to manually ensure that this happens gives you some advantages, right? The disadvantage, of course, is you have to do it manually, you have to do it yourself. But the advantage is that you can control it. So if you want to control, for example, the length of this array, you can do so and make sure that only the last couple of iterations are in this array. Or you might want to, in a longer conversation, you might want to summarize the conversation and store less of all of this text within this array. Because ultimately, this array, this text is going to be sent in your prompt to the model. This results in a prompt. A prompt is tokens, and tokens cost money. So of course, making sure you manage this array properly is a key piece that you have to do with the Chat Completions API. So if we summarize that, the Chat Completions API is a stateless API. And that's very important. It's stateless, of course, in contrast with the Assistant API that we'll see in a moment. You either have to send your state, your chat history from the client application, which could be a web app, for instance, or if you use an intermediary API that your web app is talking to, you could actually store it server-side as well in any shape or form you want to. This API does text responses only. Now, that sounds kind of logical because you're working here with an LLM, a large language model, but you'll see that because of the use of things like code interpreter and so on in the Assistance API, that you can have other types of responses in that API. If you want to make your chat interactions a bit smarter, this Chat Completions API does support function calling. And if you use a more recent model, parallel function calling, so calling multiple functions at once. A function is basically telling a model that, hey, if you cannot answer a user's question, like if the user is asking what are the top sales last quarter with a sales assistant of some sorts, then the model cannot answer this, but you provided a function that it might think can bring the answer. It can then tell the developer, should call a function first with these parameters and give me the results of that function for me to then include in the response to the end user. And you can, of course, do quite some nifty things with function calling. Now, in this Chat Completions API, there is no built-in tools support. So if you want to do something advanced, like use a Python sandbox to build some Python code and run that and get a response, you are actually on your own. You have to do that in some other way. And there are ways around that. But if you are a ChatGPT Plus subscriber and soon also in Copilot Pro of Microsoft, well, then you will know that there's a tool called the Code Interpreter. In ChatGPT Plus, when you ask for a more complex message that typically involves math of some sorts, then the Code Interpreter can be used. The LLM is going to write some Python code to solve that, let's say, math-related question, and then the result of the Python code is given to the LLM to respond to the user. You can't actually have these tools out of the box. You cannot add it to the chat completions API. And that's of course different in the Assistance API. Now, the Assistance API is also different in the fact that you can create the Assistance API in the Azure OpenAI portal. And an assistant always has a name and instructions that basically serve as the system prompt, and they always use a chat model. So a basic assistant just has that, name, instructions, and a model, and then you can start working with the assistant. But an assistant, of course, is only useful if it has certain tools to work with. Now, tools can be the functions I just talked about. That's the same as in the chat completions API. But in this case, also some built-in tools can be added. So the code interpreter tool I talked about a moment ago can be added by simply checking a box in the Azure OpenAI portal, for instance. Now, what is coming soon in Azure OpenAI is also a retrieval tool. That tool works together with file content that you upload to your assistant. And by the way, this retrieval tool is supported in OpenAI directly, so you can actually try it there and get a taste of what it will do, what it can do when it's enabled also in Azure OpenAI. Now, the content that you can upload to an assistant is of course limited. And today that's limited at 20 files per assistant and 512 megabytes per file. Files like Word documents, PowerPoints, PDFs, and so on, they're all supported. That does mean, of course, that you cannot use the assistant to query out of the box very large knowledge bases. So you still will have to interact with something like a vector store that stores a lot of content outside the Assistance API, and maybe use a function, a tool, to interact with that vector store. Now, one of the key components of this Assistance API is that the fact that it is stateful. It manages chat history for you. That's an advantage for the developer because it makes it very easy to just send a message and get a response back, and the system takes care of what was said before. It can also be a disadvantage because you have no way today to really control how chat history works. And what the Assistance API is going to try and do is to fill the entire context or the token limit of the context window of the model. So if you're using a model, for example, with a 32,000 token context limit, then if a user really wants to have a very, very, very long conversation with an assistant, every time that a new message is added, you'll basically consume the entire token limit. And the Assistance API only starts truncating messages when that token limit is reached. So that can of course be very expensive, but later tools will come to control the chat history. For example, maybe set a limit on the amount of interactions, and maybe also an automatic system that summarizes the chat history for you. That's not available yet today, so today you have to know that this is somewhat of a limitation. Now, you might ask the question, why was this Assistance API actually brought into life? Well, it is actually created to support things like custom GPTs. If you're a ChatGPT Plus subscriber, then you know that there is this place where you can go to and click on these GPTs that provide you with specific functionality. Well, these GPTs, they are built on top of the Assistance API. If you take an example of Wolfram, that's basically a GPT that you can ask complicated questions or more complicated questions, which are math related, they are scientific related questions, and so on. And this Wolfram GPT or assistant in the backend has a tool to connect to the Wolfram API and use the Wolfram language to ask questions about these kinds of subjects, right? So this Assistant API is used to support all of this. Microsoft with Copilot Pro will also support these kinds of custom GPTs, and they will also be built on this Assistance API. Now, before we go to examples, how do you use this API? Well, you use the API first of all at the start by creating an assistant. You can do this in the portal or in code, and you can reference an existing assistant that you created earlier. An important concept to know is the concept of a thread. A thread is something that is kept server-side, so it's stateful, and that keeps your messages. So when you create a thread, you basically have to start adding messages to that thread. But just adding a message to the thread doesn't do that much. What it does do is it provides context to the model for use in a run. And now the run actually brings the thread and the assistant together. Before, the thread is actually not related to an assistant. It's an entity on its own. And I can select to run the thread on any assistant I have. So in this case, I run the thread on one of my assistants, and then the assistant will use all the tools at its disposal to answer based on the message the user added. Now, it's important here to know that the answer in that message on that thread could contain more than just text. It could be text, usually it will be text, but also, for example, if the assistant decides to use something like code interpreter and it creates, for example, an image, maybe a plot of some sorts or a graphic of some sorts, then that will be a file response. You are then responsible as a developer to retrieve that file from Azure OpenAI and to incorporate that into your application. Put it visually, it's an example from the documentation. You create the assistant first, it's a separate entity. Then you create the thread, that's a separate entity as well. Then in your UI, the user is adding a message. And if you want this message to be answered, then you are going to create a run that you see here. In a run, the assistant and the thread are combined together. So the assistant runs the thread basically. And here the assistant decides to use the tool code interpreter. So it has written some Python code, and the result of that Python code is going to be used to put a new message on the thread here. And then you, as a developer, you can decide to display that message any which way you want. Okay, enough talking, I think. Let's take a look at some code to see how this all works. And I have a couple of Python notebooks in a repo on GitHub, and in the video description you'll find the link to that repo. We're going to start from Azure OpenAI Studio, and I've opened Azure OpenAI Studio on the assistants playground. Now, of course, an assistant needs a model, and just to be complete, I deployed a model and I called it GPT-4 Preview, which is using GPT-4 Turbo from 11.06. That's a preview model here. I can, of course, also use GPT-3.5 Turbo with my assistant. Then in the assistants preview, which is new in the Azure OpenAI Studio here, you can see that I can define my assistant. I can also open previously created assistants and then modify them and so on, right? So you can create multiple assistants and they are saved in the region where this OpenAI instance is deployed. In my case, I'm creating an HR assistant, so I give it a name and I also give it custom instructions. I won't read them all, but one of the things that I'm saying is you can answer questions about HR policy from the HR query function. And that is actually a function that we are going to call in our code later, but I define the function here because here is the tools section. And as I explained earlier, you can either have your own tools, which are also called functions, a little bit confusing sometimes, and then you can have the built-in tools, like in this case, code interpreter. As you can see here, the retrieval tool is not available yet. So if I'm clicking on the custom function HR query, what you're actually seeing here is indeed just the definition of that function. So the function has a name, HR query, and then it has a parameter of type string. And I have to describe to the model, what can the function do and what is the parameter actually used for, so that the model can actually decide to call this function when the user has an HR related question. We can already test that here in this chat window. For example, if I'm asking, can I wear short pants at the office? But I will just ask, can I wear short pants? What we should see here is that there is no response from the model, but in text, but there is a response that says, hey, you need to call a certain function first. So this is what the model responds with. My function, my real function in the Python code, I will show you later, can then, for example, do a search somewhere in a database or some other kind of thing it can do. I'm just going to say, yes, you are allowed to wear short pants. And this is the result of the function. I submit this to the assistant. And what you'll see now is it tries to do a response. And during the preview, you sometimes see that it's stuck on the first word and doesn't give you the full response here. Now, what it also shows you here at the right is all the logs here. So all the different API calls that you can do to work with assistants. That is something that's actually great to have because it gives you an example of what you have to send and what you can expect back. And for example, creating a thread, that was this here. I created a thread by doing a post operation to the OpenAI threads endpoint, and then I get something like a thread ID back, right? Like a unique number for the thread. If I want to add a message to the thread, I'm calling this post operation here, of course, with a certain body that contains my question. And here is the request body that you can send. And of course, this is the response of the message. So here you can learn what you have to send to the API, what you get back from the API. Of course, we will use a Python library to make sure we don't have to work with all of this just in JSON, and we will just use the OpenAI Python library. Let's take a look now at the notebook. Now let's look at how to create an assistant with code. Now, I wanted to first show you how to work with an assistant and retrieval, but then when I noticed retrieval was not available in Azure OpenAI, I modified the files notebook you can see here with a function and then external retrieval method. So normally I would upload files and then use the retrieval type tool here, but we can't do that yet today. So how do we start with this? Well, the first thing we're going to do is, of course, make sure we have our OpenAI client here, or Azure OpenAI client ready with our OpenAI key and the OpenAI endpoint over here. Then we're going to, just as an example, going to create a Chroma in-memory vector store. So that's a vector database, and I'm going to use LangChain here to quickly just load a PDF. I'm going to split the text in that PDF with some overlap. And I'm going to store those splits in Chroma with the from documents function. And now I have a vector database where I can do a similarity search. And here I'm asking for, give me 3 similar pieces of text that are similar to the question, can I wear short pants? And indeed, in this case, we get a response back, an array of 3 objects of type document. That's a LangChain type of object. Now, of course, to call this function in my code and get a response, I'm going to create a real Python function for it. This Python function does nothing more than indeed using that database in the notebook and then getting all the results and converting it to JSON. So if I'm asking the same question, can I wear short pants, to this code, what you'll see is, in this case, you will see plain JSON here. Now I can create my assistant. Of course, I already created my assistant in the portal. So if I want to create or use an existing assistant, well, I could, for example, save the assistant ID in a file and then use that file to open it and get the ID out. I'm actually doing that here. So I'm opening that file and I'm retrieving the assistant ID. If it's not existing, well, only then I'm going to create a new assistant with the client beta assistance create method you see there. And this is the same content you provide in the portal. So here you see the name which says HR assistant, the custom instruction that we provide, and then instead of using a UI, we provide a list of tools for this assistant. There are 2 or 3 tools here. The first one is a function to request a raise. And the nice thing is it's always approved. The second function is the HR query function that I already talked about, with the good descriptions of the function itself and the parameters. And I also want to enable the code interpreter here. The model is using GPT-4 preview. Now, just as an example, if we could enable the code retrieval tool, then I could specify the file IDs that I want this assistant to work with. And the file IDs would be actually retrieved by, for example, uploading files right from within code. You could even upload files with this snippet here that's uploading a file to the to Azure OpenAI, to that instance, and then that file can be used, referenced by the assistant. So be aware, uploading is not enough. You have to upload a file that's outside the assistant and then refer to the file by providing 1 or more IDs in the file IDs parameter. Now, this means that this results in getting the assistant created, and that gives me an assistant ID that I can now refer to run my threads on, as you have seen a moment ago. But we first have to create a thread. Well, creating a thread is a simple thing. We just need to say client beta threads create. And by the way, note the beta thing here. Indeed, this is a beta API. So within the OpenAI package, you also have to include there the beta setting. When we run this code, we get a thread ID back. And this thread ID can then be used to add messages to. Well, let's do that. Let's add a message. And the message I'm going to add is, what company cars can I get? I expect that the result here will be a list of company cars that I can use. Now, it's important to note here that when you create a message, it doesn't do anything. You have to run this message. And here you see that when I'm calling this client beta threads run create, now I'm bringing the thread ID and the assistant ID together. And this means the assistant will look at the messages on the thread and try to answer based on those messages. Now, doing this run is actually something asynchronous. This happens in the cloud, is fired off, and this returns immediately in your code. So you have to write some kind of helper function. In this case, that's the wait for run helper function that is going to check, okay, while the status of the run is still queued or in progress, well, try and check the status again, sleep a while, and only return the run when the status is, for example, completed or there's an error. Now, in my case, I expect it to always complete correctly. So when I wait for the run, I have a run object back, and I can print indeed the JSON of this run. Now, the JSON of this run, you can look for it. It will not contain a response to the user. Just like in the portal, you have seen that when I'm asking an HR-related question, well, then I hope, of course, that the HR query function needs to be called. And indeed, the assistant says this. The assistant says, hey, there is action required. You have to submit tool outputs. That means you have to run a tool and give me the result of the tool. It tells me what tool calls I have to do. In my case, only one. I need to call the tool, aka function, HR query, and it proposes the argument. It says, well, the argument is what company cars are available for employees. Notice that the model rephrased the question somewhat here. It's not the same as the original question. My original question was, what company cars can I get, right? So that can happen, that it modifies a bit the parameters for you. So when we have now run this function, or we have run, the thread, we have a run object. We can use that run object to check if we need actions to be performed. I just showed that the run object indicates this in the JSON, but in code I have to check for this. So if required action is indeed available, I'm going to ask for what are the tool calls that you need. And then I'm going to run all the tools in the list of tool calls. But I'm first creating an empty array called tool outputs. Then I iterate through all the tool calls here. Every tool call will of course have something like a function name. So that will be func name and arguments. And now we can use a very simple way of checking it. If the function name or the func name is HR query, we're going to run the HR query function with the arguments that were actually supplied by the model as well. And we're going to save the result in the result variable. What I have to do now is, if I have to run multiple tools, I have to append or I have to save the outputs of these tools. I have to save them into a structure that connects the output to the ID of the tool call. Every tool call gets a unique ID because the model needs to know I've asked for, let's say, 2 tool calls with ID 1 and 2. Well, you have to tell me what is the output of 1 and the output of 2. And you have to submit these tool outputs over here. You can see that here there's a method called submit tool outputs, and there I'm going to again connect the thread ID and the run together, but also provide the tool outputs in this list. This is also a run, but it's a special type of run that submits tool outputs. That means we also use the wait for run function here to basically get a response back. So we run this check for actions, and indeed I've printed them out a bit. It tells me what kind of tool calls I have to do, and it tells me, yeah, you have to call a function, and here are the arguments. Now, when I submit the tool calls, I expect that there is now also a message that I can show to the user. So what I'm doing here is I'm just gonna pretty print the thread messages by basically iterating through all the messages. You can list the messages in a thread by using this list method. And I'm going to iterate through the data field of the messages in JSON, but in reversed order. And now I have to also take into account that the assistant can return text, but also an image file. So if there is text in the content of the message, I'm going to print first of all the role icon, user or assistant, and then I'm going to print the text. But if there's an image file, and that could be if I use the code interpreter and the code interpreter has sent me an image, like a plot for instance, then I have to check if there's an image file, and that image file will be available at Azure OpenAI. I have to download it from there first, and then I can choose any method I want to visualize this image content. Here we do that in a notebook with pill and so on. Now, the result of this pretty printing in my case is this. What company cars can I get? The result from the assistant is this. And that's of course because the HR query function, so the HR query function here, the result of the HR query function will be snippets of text that contain information about my question. So it used that information to basically extract that from the document and then to print that out to me. Hey, we can use Teslas, BMWs, and so on, and yeah, some cars are disallowed as well. Now, if I ask a more complex question, for example, I add another message to the thread with a create here, and I'm asking 2 things. What are the salary levels? And visualize them for me in a high-low plot. Well, in that case, I would expect that first of all, the HR query function is run, and that the result of HR query are used to go to code interpreter, and that code interpreter creates a visualization for this. Now, what I have to do here again is I'm creating the message, I'm doing a run, I wait for the run, I check for the actions, and then I just pretty print everything. Now, I do pretty print everything from the beginning, so you see the original question as well. And here you see the new question. What are these salary levels? And notice here that, of course, if I'm doing the check for actions, it will run the HR query function again and try to find the salary levels at the company. But then it is using that code interpreter tool automatically. I don't have to, in my code, account for running code interpreter. The system is doing that for me. And in this case, it tried its best to create a diagram that in some way displays the salary levels at the company. And by the way, I'm not sure if that's a real company. I invented that, but if it's a real company, then of course, these are not the salary levels of that company. Okay, so this is basically the entire code as an introduction, of course, to the Assistants API, where you have seen things like functions, you have seen things like the built-in tools, and you've also seen how to put messages on a thread, how to run them, and how to visualize images that you get back from the assistant. Now let's get back to the pros and cons and finish this presentation. Let's end this with a couple of finishing slides here. First of all, the pros of the Assistant API. I think it's clear you don't have to manage a chat history, which makes things quite a lot simpler. And you can use built-in tools like Code Interpreter and soon also a retrieval tool. And you can imagine also a future where other kinds of tools will be added to implement assistants in an even easier way. It's also quite easy to implement RAG, Retrieval Augmented Generation. You just upload your files and they are chunked, vectorized and queried for you automatically. Now, there are some drawbacks to this as well. First of all, today there's no real control over chat history and it can fill up your entire token limit of the model, and that can become quite costly if you have longer and longer conversations with quite a lot of users. There's also an extra cost involved to run Code Interpreter and retrieval tools, and depending on your application and how it is used, that can be significant. RAG is of course also a black box. If you've ever created RAG applications, you know that for some use cases, you have to do some optimizations at how you implement splitting, for example, on your documents. And you cannot really control how that is done in this API. What's also great to see today is that the Assistants API is getting support from other tools, but also frameworks. For example, a framework like Semantic Kernel has support and showcased some support for the assistants here. And they also have this idea of letting these assistants talk to each other to solve a task divided over multiple assistants. Of course, LangChain has support for the Assistants API. The question is, what does LangChain not support? And also the Vercel AI SDK has some experimental support for the Assistants framework. And also a tool like Flowwise that allows you to build visually these kind of flows also supports OpenAI assistants, which makes it very easy, for example, to provide these assistants with custom tools. So there's a lot of things that are using this framework. As a conclusion, I would say today for production applications, keep on working with chat completions. That remains the primary API today and is the go-to API to use. But you should start evaluating the Assistants API, see how you like it, see how you like the Python package, for instance, just because of the fact that it manages chat history for you and you have access to these tools like Code Interpreter. All right, that's it. Thank you for watching and see you in some other video. Bye-bye.